Here we have a SAT math question. Okay, let's go to the problem. F of x equals to 2x cube positive 6x square positive 4x. G of x equals to x square positive 3x positive 2. The polynomial functions f of x and g of x are defined above. Which of the polynomial functions is divisible by 2x positive 3? Okay, for that what we have to do is first we have to get the factor form of the two polynomial functions f of x and g of x, and then we have to verify each option. Okay, first let me take the given function f of x, polynomial function, that is equal to 2x to the third power positive 6x square positive 4x. Okay, now let me get the factor form of this one. Okay, f of x equals to, what's the greatest common divisor for all the three terms we have over here? That's clearly 2x. So we can factor 2x out from the terms of this polynomial function. When 2x is factored out, to get the stuff inside the parenthesis, we have to divide each term in this expression by the one I factored, that is 2x. Okay, when I divide this 2x cube by this 2x, I am getting x square. When I divide this positive 6x square by this 2x, I am getting positive 3x. When I divide this positive 4x by this 2x, I am getting positive 2. Okay, here f of x equals to 2x times. Now we have to factor this quadratic expression. Okay, if I want to factor a quadratic expression, I have to multiply the constant term by the coefficient of x square. In this case, it's just 1. So when I multiply this positive 2 by this coefficient of x square 1, I am getting positive 2. Now I have to get two factors over here, so that the product of two factors equals to positive 2, and the sum of the two factors equals to the coefficient of x, that is positive 3. Okay, then we get positive 2 and positive 1. When I multiply positive 2 and positive 1, I am getting positive 2. When I add positive 2 and positive 1, I am getting positive 3. That is the coefficient of x over here. Okay, further, I have to divide both these factors by the coefficient of x square, that is 1. Okay, even when I divide positive 2 by 1, I am getting positive 2. When I divide positive 1 by 1, I am getting positive 1. Okay, now to get the first factor of this quadratic expression, I have to take x and take this factor positive 2. So x positive 2 is one of the factors of this quadratic expression. Now to get the second factor, again I have to take x and I have to consider this one, positive 1. Okay, now I got the factor form of the first polynomial function f of x, that is f of x equals to 2x times x positive 2 times x positive 1. Okay, now let me take the second polynomial function g of x. So g of x equals to, we have x square positive 3x positive 2. We have to get the factor form of this one, but already we have factored this quadratic expression over here. So its two factors are x positive 2 and x positive 1. So we can write them as this, that is x positive 2 and x positive 1. Okay, now I got the factor form of the given two polynomial function f of x and g of x. Okay, let me write this factor form and this factor form over here and continue the problem. Okay, now we can verify the given answer choices one by one. Okay, let me take the answer choice A. So in which we have h of x equals to f of x positive g of x. Then we get h of x equals to, so for this f of x, we know that 2x times x positive 2 times x positive 1, the factor form, let me plug in that. That is 2x times x positive 2 times x positive 1. And for g of x, we have the factor form x positive 2 times x positive 1. Okay, here h of x equals to, okay, here in this one, x positive 2 times x positive 1, let's assume there is 1 multiplied over here. Okay, so what do we find in common in these two terms? We find x positive 2 times x positive 1 in common, so that one can be factored out. Okay, let me do it. Let me factor x positive 2 times x positive 1. Okay, if I factor x positive 2 times x positive 1 out from these two terms, I am left with 2x in the first term and positive 1 in the second term, that is 2x positive 1. Okay, here I got this h of x in factor form over here. Okay, if this h of x is divisible by this 2x positive 3, then this 2x positive 3 must be one of the factors of the h of x. But I don't see this 2x positive 3 as one of the factors over here. So this h of x is not divisible by 2x positive 3. So we can reject the answer choice A. Okay, let me do it just a moment. So let's reject answer choice A. We can check answer choice B. That is p of x equals to, we have f of x positive 3 times g of x. Okay, p of x equals to, for f of x, we have the factor from over here, that is 2x times x positive 2 times x positive 1, positive 3 times. For g of x, we have the factor from, that is x positive 2 times x positive 1. Okay, here p of x equals to, okay, now over the same thing, we can factor x positive 2 times x positive 1 out from these two terms. Okay, let me write it x positive 2 times x positive 1. So when I factor this stuff out, I am left with 2x in the first term and positive 3 in the second term. Okay, now I got the factor form of the polynomial function p of x in answer choice B. So here in this factor form, clearly this 2x positive 3 is one of the factors. Since 2x positive 3 is one of the factors of this p of x in answer choice B, so this p of x is divisible by this 2x positive 3. So the correct answer choice for this question is B. Since the answer choice B is correct, even if we verify answer choice C and answer choice D, they won't be correct. So we can reject the other answer choices. So the correct answer choice for this question is B.